Hello everyone, this is DR.MIHIR Shah once again with another video. In this video, we're going to solve November 2018 university question paper, all the practical sum that had appeared in logistic and supply chain management subject. Again, a very important video for all the TYBMS SEM-V student. Okay, so basically there were two questions that had appeared in November 2018 university paper. We're going to solve both of them and try to understand how you need to solve them. Okay. Separate videos have been already created on the practical topics of logistic and supply chain management. So I would recommend first you all can go through that for all the formulas and all, and then you all can go through all the university question paper solved videos. Okay, chalo, let us see what are the two problem sum that had appeared in that particular paper. We are going to solve November 2018 question paper. Okay, the very first question that had appeared in this was, from the following data, calculate a 3-period weighted moving average from the 4th month to the 8th month with weight 3, 2 and 1. The largest weight is being assigned to the most recent period and current demand value. They are giving you the months 1 to 8 and demand in units. We need 4 columns: period, demand, working and 3-period working or weighted moving average. Under period, we note down 1 to 8. Under demand, 100, 120, 130, 145, 160, 170 and 200. Okay, and for the 8th year we need to find that. So remember now how to solve this. Okay, first step, since there is a 3-period, first 3 periods will be nil. We start with the 4th period, but we take the first 3 values, and the latest being multiplied with the first weight, which is 3, the second being multiplied with the second weight, and the first being multiplied with the first. So basically it will be 130 into 3 plus 120 into 2 plus 100 into 1 comes to 730 divided by 6, that is the total of weight, 3 plus 2 plus 1. So 730 divided by 6, we get the value as 122. Similarly, next we take the next 3. So 145 is the latest, 145 into 3 plus 130 into 2 plus 120 into 1. Total comes to 815. Again we divide that by 6, we get the value as 136. Next, the next 3 is from 130, 145 and 160. So we multiply 160 into 3 plus 145 into 2 plus 130 into 1. Total comes to 900. 900 divided by 6, we get it as 150. Next, from 145 to 170. So 170 into 3 plus 160 into 2 plus 145 into 1. Total is 975. Divided by 6, we get the value as 163. And the last, 160 to 200. So 200 into 3 plus 170 into 2 plus 160 into 1. Total is 1100. Divided by 6, we get the value as 183. Okay, so this is how you all had to basically solve the 3-period weighted moving average problem sum which had appeared in that paper. So whenever they give you this 3, for the first 3 columns will remain nil. Thereafter we have to take from the 4th year onwards, multiply with the weights, the latest being multiplied with the first weight, the middle one will be the second weight, and the very first one will be with the first weight. Multiply, add up, divide by 6 because the total weight ka value was 6. Okay, divide and you will get your final answer. Okay, so this is how you all had to solve the first sum which was asked in that particular question paper. So I'll give you all a couple of seconds to at least go through it and take a screenshot of it and solve it. And thereafter we will move to the next sum, the second sum which was asked in that paper. Okay, let us see the next question which had been appeared. The question reads as, the annual demand for a particular item is 9,000 units. The unit cost is rupees 10. The carrying cost is 20% and the ordering cost was 150 rupees. Find EOQ, total inventory cost, and third, if purchase manager decided to place a purchase order with minimum quantity of 3,000 units to get the unit cost discount, state the purchase manager is justified in his decision or not. So the first and the second thing that they have asked will come under one part, and the third one is the next part altogether. Okay, so first we note down the data which they have given us. Annual demand is 9,000 units. Unit cost is 10 rupees. C carrying cost is 20%, so it will be 20% of CPU, so 10 into 20% is rupees 2, and ordering cost is 150. Once we have A, O and C, we can apply into the formula. EOQ is equal to 2 into A into O divided by C. So 2 into 9000 into 150 divided by 2. The square root of that we get it as in point form, so rounded up to 1162 units. So our EOQ will be 1162 units. That was the first part of the problem sum. They asked us to find the EOQ. Second, they asked us to find total inventory cost. Now in order to find the total inventory cost, you require three things. So first, you need material cost. So see, this is the formula. Total inventory cost is equal to material cost plus ordering cost plus inventory carrying cost. I need first material cost. Material cost ka formula is material cost is equal to A into P, that is A into CPU. So 9000 into 10, which is 9000 rupees. That's the very first thing that is required to be found. Second is ordering cost. Total ordering cost ka formula is A upon EOQ into O. Annual demand is 9000. EOQ was 1162 into O, which is 150. So 9000 divided by 1162 into 150, we got the value as 1162. Third, we need inventory carrying cost. Inventory carrying cost is half into EOQ into C. That is half into EOQ was 1162 into C is 2. So we again multiplied and divided. We got the value as rupees 1162. Once we have all the three values, we can apply into the formula. So 90,000 plus 1162 plus 1162. Final answer is rupees 92,324 rupees as per the second part that they wanted to find total inventory cost. Now third one, they are asking us, okay, what if the manager has given an EOQ of 3000 unit, he will get a discount of 10%, then will it be justified? So now again we need to find the new total inventory cost, and if the inventory cost is less than 92,000, it will be a justified value. Okay, so the third part to start, remember the EOQ now they told is we have to take the EOQ as 3000, so we'll have to change the data now. Okay, so chalo, we'll see how we go. So the new data, EOQ is 3000. When we take the EOQ 3000, we'll get a discount of 10% on CPU. Cost was 10, so 10 minus 10% is rupees 9. Carrying cost is 20%, so we get 20% of 9 rupees, which is 1.8. The ordering cost is 150 and the annual demand is 9000. So since the EOQ is directly given to us, we can directly find the material cost. So material cost is A into P, so that will be 9000 into 9, which is 81,000. Ordering cost is A upon EOQ into O. A is 9000. EOQ is the new value which we got 3000 into 150 is O. 9000 divided by 3000 into 150 is rupees 450. Third is inventory carrying cost, half into EOQ into C, half into 3000 into C is the new C 1.8. So half of 3000 into 1.8 into 1.8, we get the value as 2700. When we add up all three, the new inventory cost will be A plus B plus C. This was the A value, B and C is already there. We add up 81,000 plus 450 plus 2700 is 84,150. Now this value is lesser. The previous inventory we got 92,000 plus, this is 84,000. So since the manager decided to get the EOQ to 3000, the total inventory cost has reduced to 84,000. Hence it is a justified decision that the purchase manager has taken. It is a good decision. So we'll write the final answer. Yes, it is justified to go with the order quantity of 3000 units, since there is a reduction in the value of or total value of or the total cost. Okay. So this is how you all had to solve the second problem sum, question number 4A, which was asked in the question paper. First EOQ, then total inventory, and then you have to find the new total inventory cost and say which one is better among the two. Chalo, these were the two problem sums that had appeared in November 2018 question paper. I hope everyone have understood that. Chalo, with that we will be ending this video here. Thank you.